Hi everyone, welcome to the first session of Sci-ROI India virtual launch event, a conversation with forerunners in Indian STEM. We have a great list of panelists here. In this, we'll have a panel discussion with our established scientists in India who are pioneers in their field about their experiences in setting up labs in India, forming new collaborations, selecting students, and picking up various relevant research topics and many other questions they'll be answering. I'll go ahead and start introducing our panelists. First of all, Professor Gagandeep Kang. Professor Kang, she's a microbiologist and virologist with a focus on viral infections in children. She's the first Indian woman scientist to be elected as a fellow of the Royal Society. She has received various awards and acknowledgements, including the Infosys Prize in Life Sciences and Indian National Award for Women Bioscientists. Currently, she is a professor in the Department of Gastrointestinal Sciences at the Christian Medical College in Vellore, India. Our next panelist, Professor Rohini Godbole. She's a physicist with academic specializing in elementary particle physics. She is an elected fellow of all the three academies of science in India, and also the Science Academy of the Developing World, also known as SQUAS. She has received various awards and acknowledgement, notably Padma Shri by the Government of India, National Order of Merit by the French government, and the S.N. Bose Medal for Theoretical Physics of the Indian National Science Academy. Currently, she is serving as professor at the Center for High Energy Physics, IISc Bangalore. Next on our panel is Professor Kankan Bhattacharya. He is modern nonlinear laser spectroscopy scientist. His primary discovery is the ultra-slow nature of biological water. He's a former director and chair of Indian Association for the Cultivation of Science, Kolkata. He's also fellow of all the National Science Academies of India and a senior editor of the Journal of Physical Chemistry. He has also received several awards, notably the Shanti Swarup Bhatnagar Award in the Chemical Science from CSIR and the Ross Prize. Currently, he's an adjunct faculty at the Department of Chemistry, IISc Bhopal. Our next panelist, Dr. R. Nagarajan. His research focus is on clean room processes, nanotechnology, and ultrasonic process intensification. He has received many awards, including several IBM Innovation and Performance Awards and Team Awards, Strategic Partner Award from Beacon University, and 50 Most Impactful Social Innovators by Social Innovation Conference. Currently, he is serving as professor at the Department of Chemical Engineering and also Dean of International and Alumni Relations at IIT Madras. Our final panelist, Professor Saumak Rai Chaudhary, he's an astrophysicist known for his work on stellar mass black holes and supermassive black holes. He has received various awards, including Smith's Prize from University of Cambridge and Douglas Leading Essay Prize from Trinity College, Oxford. He is currently director of Inter-University Center for Astronomy and Astrophysics, IUCAA Pune. And with in this panel discussion, we'll cover various topics. Our panelists will cover various topics, including how we can start our independent position in India, how we can start our own new lab, and how we can manage various difficulties we probably will face while managing the lab, and what are the opportunity landscape in India. And with this, I'll hand over the panel discussion to Shubhashish Haldar as a moderator. Thank you.
Thank you so much, Devesh. So I'm really proud to host the panel where every panelist is one of the stalwarts in their respective fields. And, for me, this is also my favorite panel because I knew many of the panelists for a long time. So it's actually a great pleasure for me as well. So let's start the session. So in the beginning, maybe, I could start the discussion with Shomukta. Okay, Professor Raichowdhury, I mostly speak with Shomukta, so I think this is fine. So Shomukta, my question to you is that when you decided to come back India as a PI, why you actually wanted to come back to India, and what was your first experience when you landed here?
Right. So that's a interesting question. Good to see you. My coming back to India was complicated because I came back twice. I came back once in my early 30s, worked in my first faculty job in IUCA Pune here, where I am now, for 5 years. Then went back into the European system again, and came back about 15 years later in a different role. So, but there are the underlying reasons were the same. One is personal. Of course, I am a product of some of the best undergraduate education in the world. I went to Presidency College in Calcutta, and I think that the time I spent there, I was taught by some of the best people ever in teaching in India in my subject, and before that, school education, etc. So very personally, I always wanted to make sure that I did the same when I became a professional myself to train Indian students and give back whatever I got as a student myself. That was always at the back of my head, and so I made attempts to come back. I think the first time I came back and went back out again, I always thought I'd come back. And so the second time I came back is important because the context was that, as you know, Presidency College was being upgraded into Presidency University, and I was invited to come back as a senior professor there, as a dean. And so I came back because then I thought I could make the contribution more. But that's my personal reason. Second thing I think is important in the context today is that whatever the work is, and science is often seen as impersonal, science is often seen as universal, but it is always important to see science in the context of where it is being done. And in my case too, even though I deal with stars and galaxies, which are nowhere on Earth, but it is important to see who I work with and in what place I do it in, and what tools I use, and what people I work with, the students I work with, etc. And so the context of the work is very important, and that is why there is an Indian science, even though science is universal. And I wanted to be part of it. I felt that I could make much more of a difference to the science in India than I could do in an institution in the West. And both of these attempts to come back were motivated by that, and in at different levels of life. And so I'm sure a lot of people here would be considering this coming back to India, different parts of their life, and I've done both, right? So yeah, so I think that can start this discussion. I'm sure everybody here would have a very interesting angle to this coming back question.
That's true. Maybe I can go to Gagandeep. Gagandeep, can you share your story that, what is your experience when you came back, and, why you wanted to come back to India?
Well, I think mine is a little bit different from everybody else's because I was already on the faculty here and then went for additional training, study leave from CMC. But, when you do well overseas, you always have the opportunity to stay where you are. And it does then become a choice. Do I stay? Do I come back? If I come back, why? And what am I going to do? When the ease of doing science in the West is very seductive. You feel like you can get so much more done there. So I actually had to think about the fact that if I needed to come back to India, there needed to be a driver. And for me, the driver was that as somebody who had a medical qualification and understood the laboratory, I felt like if I stayed in the US, I would be doing what a gazillion other physician scientists in the US do. But in India, you look at physician scientists and the numbers you can count pretty much on your fingers and toes, which is a bit ridiculous for a population of our size. That was the main motivation. I could do things in India that other people were not doing.
And again, if I come to the same question to Rohini, and maybe, I can add some points to that. Rohini, would love to know your experience, and as well as when you started the lab, how you were started to address the question, like, do you have short-term goal, or do you also basically started long-term goal in the beginning?
Okay.
So would love to know your experience, and then maybe, with your goals, how you started your lab.
Okay. So I should tell you this, that there are two comments that I want to make about coming back to India, in fact. So I came back right after I finished my PhD in the US. So now I know that perhaps that was not, somehow one should actually gain. So I was not a ripe researcher who made a decision. This was a young person who had been away in the US for 5 years, away from India, and kind of felt now this is enough staying outside. This is 1979. So it's a pretty different world. I just wanted to be home because I used to do a lot of social work before I went as a student in IIT and so on. And there was this thing always that I want to be involved with society at large. And therefore, somehow, right after I did my PhD, I said, I'm going back. This was even when I had actually 2 offers to stay, one in Europe and one in the US. So my experience of coming back is kind of somewhat different, in the context of this discussion. But I want to make a point here, actually, and that's why I'm saying this all, is that I feel that I feel that this, it's only now I feel this after 40 years, that this actually I consider as an evidence of a negative mentoring that, women normally receive. Because if I were my advisor, and when I had already offers and they were good offers, I would have told my student that you need to stay and get more experience and be your own person. Because I think in science, you become your own person and sort of get what it takes to start a lab only after you have had some amount of postdoctoral experience. Okay, it's another matter altogether that I came back to the best place to do particle physics in India at that time. That was the Tata Institute. And it's quite another matter that luckily, whatever I did, whatever I chose to do was successful. And this particular thing didn't affect my further progress, didn't stall me. But I wanted to mention this thing that it's only now that I realized this. So this is about, but nonetheless, I think it was very good because I came back and I could be involved in, we used to teach in the neighborhood basti to women reading and writing, or at that time a big thing was nuclear bomb. So we wanted to have social lectures. So those things I could do. So for me, coming back was from a very different perspective, but nonetheless, I didn't suffer from the negative points that it could have had. And now this brings me, second question that you said, because when this 79, particle physics, particularly in the area in which I work, which works very closely with the data, communications were not so fast. So we didn't have many big groups which were doing phenomenology. Luckily, I was in one place where there were 2 good phenomenologists. And one of them was Professor D.P. Roy. And it was in these 2 years that I actually set up the questions that you're asking, that how do I learn, what research topic to choose? Because I'm a theorist, so there is not much of a lab setting up, but the setting up is of collaborations. The setting up is of interactions with people. And there, I think it was really you took the most challenging issue that was there at that time. And for example, since again, as I am a phenomenologist, my most important work at that time was actually how can one suggest to the experimentalist methods to look for the particle, which was the Higgs boson, and the top quark, which were the 2 last missing members of the periodic table of particle physics. So these were big questions. So my research choices were certainly affected by at least certainly because of the big questions. So that is I was not looking at small things, but I was choosing these because these were important questions. And as luck would have it, I could make important contributions. But I think aiming big, according to me, you should judge whether you have the ability, and that only you can judge. But this would be my advice to the young people. Aim for the sky. You can do it. Think of big problems. So that's it.
Fantastic. So really inspiring. So yeah, I'm coming to Kankan Bhattacharya, Professor Kankan Bhattacharya. So, but let me add the discussion in my ways. So when I was doing my PhD, Kankanda was in cultivation of science, he's the director of there, and then he's very well known, right? He's very well known with the physical chemistry. But while I'm doing my PhD, he started to working on cells, right? And especially he's doing FCS on the cells. So Kankanda, I would like to know your experience, especially why you wanted to come back. But then I also like to know the story while you were transitioning from physical chemistry to little bit biology, not little bit, it's actually cell biology, a whole world. And I just wanted to know that, what the challenges you faces that time and how you overcome that one, kind of your journey from physical chemistry to biology.
Thank you, Subhashish. Actually, I came back because I strongly believe that good things can be done in India. And secondly, I thought that if I do something good in India, at least even if I don't publish any paper, if I train some students, they will also pass the training or knowledge to the next generation. And I think I am more proud, not because of my awards and papers, that I have produced many, many good students. Out of my 32 PhD students, 28 are now faculties of India. And my grad students are another 25. So about 50 students and grad students I have produced, and that is my biggest pride. And they are, I think 16 of them are IIT faculties, 6 are in ISARS, JNU, and you name it, at NITs, Saha Institute of Nuclear Physics, SN Bose Center everywhere. The reason why I started doing biology, I don't know anything about biology. I did not even have biology as a 4th subject in the higher secondary. What happened is, when I was doing postdoc at Columbia, I came back in 1987, 35 years ago. I was getting trained by femtosecond laser spectroscopy. This field has not yet got the Nobel Prize. The first Nobel Prize was given to Ahmed Zoil in 12 years later, 1999. And the next one was given in very recently, 2018, in Physics Nobel Prize. But I know this is my expertise area, but I always think of 2 kinds of research. One is short term. What short term means whatever is available in the lab. If you don't have a beaker and a piece of paper, I have to do something. Second is, I knew at those times getting money to set up a laser is very difficult. So I knew, I had a confidence I will get the money, but it will take 5-6 years. I thought, what will be the problem 5 and 6 years from now? So that was a long-term vision. And I found that most of the femtosecond or ultrafast spectroscopists are working on simple liquids. And there is a vast subject called complex fluids, where the physics says soft matters, where the chemists say, which there's a Nobel Prize in 87, supramolecular assembly. I said, these are the area where these ultrafast lasers were not applied. So I thought that I will slowly build up. So I have trained my student that learn lasers and also learn how to work with protein, DNA, this and that. And then from time resolution, I got interested in microscopy, spatial resolution. Actually, I learned many things from your work. I read many of your papers, because when I started this confocal microscopy, FCS, I did not have a background of PhD or postdoc or whatever. So then I thought that what I can do different from other people in the field, because biologists were taking pictures. They use confocal microscopy only to take photographs or pictures. But I am a physical chemist, so I need to do spectroscopy, kinetics in picosecond, second to picosecond time scale. And somebody said, you see that you should have your own cell culture lab. So when I applied for a cell culture lab, I told the funding authority. Actually, I am very fortunate. The DST and CSI supported me for 30 years. From 1990 to 1920, I got projects. Now I have retired. I don't have a project. So I went into cell. My philosophy was that a microscope has a spatial resolution was 0.2 micron and cells are 20 micron. So I can see different parts of a cell. And I can divide a cell into 100 parts. There are biologists already know which probe goes to mitochondria, which goes to lipid droplets, which goes to nucleus, what is a siRNA. So I started doing it, and somebody said, you see that you start with cancer cells because cancer cells survive very easily. So I started comparing cancer cell and live cell, and we got lot of differences, which I think have implications in the kinetics of gene silencing, which I did. We showed there is something called a stochastic resonance involved, and so it was exciting time. And the most excited was my students, and I am very, very proud of them. Thank you very much.
Great, thank you. So now let me come to Professor Nagarajan. So Nagarajan, I would also love to know, your transition period, but also I had a different question for you. You were in IIT Madras, so also addition of the research, you have to teach classes, right? So my question, I'm really wondering that how you basically balance between, teaching and, research. What is your time management? And this is a lot of questions for a lot of young PhD.
Yeah. Good evening, everyone. So I think everyone's story is a little different, and so is mine. To be perfectly honest, I was very happy in the US and had no inclinations of coming back, except for a fairly major event that happened in our life, which led to my mother passing away, and then my father was living by himself in India, and he was finding it difficult to take care of his health. So we made a decision that we should move back to India so that he could live with us. And we started planning to come back. And also, I think the other difference is I came from about 15 years in industry. I had been with IBM's storage systems division in San Jose, California, doing a lot of very interesting, not only R&D work, but also a lot of manufacturing related work, a lot of firefighting, task forces, all that kind of stuff. Very exciting and very challenging. And to come back to an academic setting, of course, IIT Madras is also my alma mater. And I was pretty much determined that if I did come back to India, first thing I wanted to come back to Chennai. I think a mistake a lot of people make when coming back is they come back to a region of India that they are not familiar with, where they have no friends, no family, and many of them wind up going back. I mean, it happened to my wife's sister, for example. So I was pretty determined that since pretty much all my family and friends were in Chennai, that's where I needed to come back to. And also, at least back in 2003, when we moved back, the Indian industry was not really in a shape where they could absorb a PhD in chemical engineering and give them meaningful work. I think that's also changed a lot in the last 20 years. So again, I was pretty much determined that I should only come back to IIT Madras. So I had already picked my city and picked my institution, and I was prepared to, if I didn't get in, I was prepared to, become a consultant or something like that, because I really had no inclination to work with any other academic institution or with industry. Somewhat of an elitist outlook, I know, but that's how I felt. And luckily, things did work out, and I did join as a professor at IIT Madras. I have had a lot of challenges in terms of balancing my work, not only between teaching and research, but also, well, within 4 years, I was kind of thrust into administration, and I have been the Dean of Alumni and International Relations for almost a decade. And right after that ended, I was had to also take over as the head of the Department of Chemical Engineering. So almost 13 years have now gone by in admin, and that's basically a full-time job on top of your research and on top of your teaching, because at least in the IIT Madras system, you don't get relief from teaching and research just because you happen to be a dean or even the director. Even the directors are expected to teach and they're expected to carry out the research, because once the term ends, you're supposed to go back to doing what you were doing before. In fact, our current, most recent director, Professor Bhaskar Ramurthy, served 2 terms as a director. Now he's back in the Department of Electrical Engineering doing, his research and teaching and all that. So it does give you a perspective that you have to kind of keep your hands in everything. You cannot just let something go just because you're very intensely involved in something else. So I do think that even without administrative duties, you're doing 2 full-time jobs at least as an academic. But when you throw in administration also, it's virtually doing 3 full-time jobs at the same time. But I do find that if you are efficient in the way you do things and you don't let work pile up, it's manageable. So one thing that I have always been known for is to, answer emails. I mean, I don't like to leave any mails in my inbox unread at the end of the day, even when I was getting hundreds of emails a day, And so I think it's just that you have to be very organized in your thinking. You have to be very organized in the way you plan your work. And you have to learn to use your time fully. It's very easy to kind of slack off because as an academic, at least in the IIT system, the Indian system in general, you have to be self-motivated. Once you become a professor, there is nothing that really provides you a huge incentive to continue to excel. And so unless you are internally driven, you can very easily coast and you will still be regarded very highly. So you have to keep challenging yourself and you have to continue to try to become a better teacher and a better researcher and a better administrator. And of course, now we have the startup culture everywhere. So you also have to mentor startups. You have to, prepare students to become successful entrepreneurs. So that's another thing on your plate. So academic life, I think, is becoming incredibly complex in India. And you just have to mentally prepare yourself to be able to juggle so many balls at the same time.
Got it. Okay, I have a question for Gagandeep. So Gagandeep, what would be your advice how many grants a young PI should write in a year? And maybe I would also love to know how much you will be, you wrote during your time as a young PI. What is a good balance?
So if you write really good grants, I think funding rates in India are higher than funding rates elsewhere. So, various committees that I've sat on, the funding rate is anywhere from 15 to 35%. It very rarely dips below 10%. So, and if you look at the kinds of institutions that get funded, they are obviously all the ones that are well known to everyone. But there are also, for good grants, there's funding that can go anywhere. I think the most important thing is making sure that you spend time on your grant before you submit it. Too often the grants that we see are grants for which people have not invested the time that is really required to make it into as strong an application as possible. I think one of the things that people don't realize is that funding agencies are there to fund. You have to make their job easier. Give them something that is ambitious enough that they can look at it if it succeeds to say, we supported that piece of work at this stage in its development. So for me, my own funding is a little different from science funding because I tend to apply for very few grants, but very large ones. So in my early career, I probably had a funding rate of somewhere around 70-80% for the grants I wrote. Most of my rejections were from, if I wrote 5 NIH grants, I would get 2. So the Indian grants, I think I've written 1 that was rejected. So I don't think it's that much of a challenge to get funding in India.
Got it. maybe I will come back. I can come back to Rohini. Rohini, I have a different question for you. When you were selecting PhD students, so what the criteria you were looking for at that time, like what is your selection procedure? How you know that? Yeah.
No, it's actually a question that bothers me a lot, because what happens is that in our it depends on, there are two streams. I mean, if the student has done undergraduate or graduate studies with you. So for example, in IISc, we have this stream of integrated PhD programs. Then choosing a student, you can be more, correct. Why? What do I mean by correct? Because it's not just for me that I'm thinking of it, because if you just a student, you see him or her for a few hours in maybe half an hour, 1 hour in the interview post MSc, you can't really judge whether the student and you are going to match. Because I think, at least in my opinion, particularly in theoretical physics where I work, research actually is a product of personality and intelligence and, how good you are in terms of technical stuff. Now, simple things like I know what kind of technical stuff expertise is required for my work, for my theoretical work. So I would clearly test the student for that, so that he or she doesn't find the particular project I give uninteresting, because that's the most important thing. But there are things such as, you need something else in research. You need a perseverance. And that is something you can judge much better when you have had the student for a while as an undergrad. And also whether you match, your wavelengths match. Because sometimes there are different types of projects. Some projects are short-term goals, the low-hanging fruit. They can give you some name or fame for a few years, but maybe after a few years, the work will lose its relevance. Sometimes you want to just sit and say, okay, this will take a long time, but the results are going to be really worth it. Now, you and the student have to have a understanding and matching of wavelengths on this. And then, sometimes depending on the student, then I would change the problem once I see what the student needs. But you can't always do that. So for me, the best way to choose a student, for the student also, from the student's point of view also, is to have had an interaction of at least a year. And which in the US, very often this happens, that you go there, the first year you're doing some courses, you are doing your master's, and in that period, you get to know different people, and then you choose to work with somebody. In India, at least in IISc, for the longest time, we would choose the student to pick up a student to work with somebody in many other departments. And I am personally very uncomfortable with that. Luckily for us, we don't do that. Even for post-MSc, we let our students come, they do their coursework in the first year. So either integrated PhD or post-MSc, I think this period when people get to know each other academically is very important. So that's what I insist on when I'm choosing a student.
Great. If Professor Nagarajan want to add something here.
I think we are very fortunate that India has such a fantastic talent pool. We supply talent all over the world, and so I don't think we are ever going to be in a situation where we are constrained by the people available to us. It's a matter of choosing from among the best, and I think
absolutely
it's a great starting point. Now, a challenge in research in India is that some of the best undergraduates don't necessarily pursue higher studies in India. It used to be that most of the best undergraduates will go abroad for higher studies, at least in engineering. Now that trend isn't there anymore. This whole brain drain is pretty much stopped now. It's been plugged completely. From IITs, for example, hardly 7 to 8% now go for higher studies abroad. which you can look at as a positive or a negative, depending on your mindset. But the downside, another downside of that is the ones who are not going for higher studies are not necessarily doing things that are, intellectually stimulating. It's not that they are now staying back and going to Indian institutions to pursue higher studies. Many of them, as I was saying earlier, become entrepreneurs, but there are many who join, consultants, fintech companies, all kinds of things, which is a different kind of brain drain, because you're certainly losing them from the science stream where they were trained. But because of that, I do think that there is a challenge in getting the best undergraduates to consider staying on to do graduate studies in India. I think a lot of us are at fault also. Many of us as role models have done our PhDs abroad, and we send our kids abroad for higher studies. And so it's difficult to talk to a student with a straight face and say that you should do your PhD in an Indian institution, because their immediate response will be, how come you didn't do it, and your kids are not doing it, so why should we do it? So that's there's a bit of hypocrisy, I know, when we try to convince. I mean, we visit universities and try to convince undergraduates to apply to IIT Madras, for example. And but I don't think we are always convinced that the effort is going to be successful, or even that we are telling them to do the right thing, because I do think that international exposure is very important also. So those are two considerations you have to balance. You don't want to keep students here just for selfish reasons. They may be excellent researchers, but will they gain more by conducting their postgraduate studies in a different environment from the one that they're used to in India? So I think you have to look at it from both viewpoints. What may be good for you may not be the best thing for the student, and certainly their wishes should take predominance over, their needs should take predominance over ours.
Great views. If I can come to Kankanda and Somogda. So Somogda, my question is that, what is the difference of mentoring a PhD student and a postdoc? What is, what do you think? What should be the mentoring process? How should that differ?
Well, I mean, one has to also realize that the culture of having postdocs is not very prevalent in India. And in particular, it's there in the sciences and in the institutes. The universities do not have postdoctoral fellowships. And the way we grow up in the system, the postdoctoral fellowship system in India actually applies to certain subjects. And much of the university system does not know about it. And so so you can have people doing PhDs abroad and coming to do postdocs in India, but then you can have people who've done PhDs within India and gone on to a postdoctoral career, and then they are seeking the best career progression. So it is actually very, very sensitive issue. This mentoring postdocs and mentoring PhD students are two different things. In the case of the mentoring postdocs, what you're doing is you are helping them get their next postdoctoral job or a faculty position, most importantly, right? So there, the nature of mentoring is very, very different, because you have somebody who's already supposed to be an experienced researcher because they have learned certain skills that have gotten their PhD. They might not be independent researchers yet, but unless they actually show some level of independence and the umbilical cord is cut from their PhD days, getting a faculty job is always very difficult, because that's one of the things the postdoc has to do in sciences to show that they're independent and they can now lead a group, and then institutions will hire them. To give them that skill and confidence is the key to mentoring a postdoctoral fellow. And that applies anywhere within the Indian system, or even if they want to go to another postdoctoral fellowship or a faculty job abroad, it is the same level of confidence that is necessary. For a PhD student, it is far more basic, because when a PhD student comes to you, as Professor Godbole said, you actually don't know how motivated they are till you actually start working with them. You take them at face value, And then you realize, you can have PhD students coming into PhDs for various reasons. I mean, it could be just, they've just rolled along. They think after BSc, MSc, a PhD is the only thing to do, right? I mean, a lot of people come to PhD for the wrong reason. Some people think there's a lot of, glamour in PhD or traveling in PhD or whatever, and they can go abroad easily and stuff like that. So you don't figure out the actual motivation of a student. And so it's very, very important for the supervisor to very early on to figure out what drives this person. And then figure out what skills this person requires to find out what their long-term goals are, because they don't know. A PhD student coming in often don't know what they want to do. Often they're very, very confused. I have found very few PhD students who actually in their first year know where they want to go, apart from some nebulous idea of they want to go abroad. And so then it's a PhD, but a postdoc is very different. They don't have this confusion. So PhD student, it is very important for the supervisor to understand what this person can become to some extent, and make sure that they acquire those skills. I sometimes think that the subject of a PhD student's research is not as important as the skills they acquire. And once they actually have a skill, often skills are transferable to many, even across disciplines. But it's absolutely important for a supervisor or PhD student to give them the skill. And so this is the very, very crucial difference between mentoring a PhD student and a postdoctoral fellow. I can see Professor Godbole wanting to say something.
No, Subhashis, may I just add one sentence?
Of course, please.
Because I just found there was so much resonance in what Somak was saying. And the important point is, at least I find, that when you have a postdoc, the postdoc mentoring is, I don't know whether it is just about, making them confident about, of course, that is there. That's a sort of a technical thing. But to me, as a postdoc level, you want to bring out to the person, give the confidence to the person that I can strike on my own in research. And you want to perhaps give it cannot be trained, but you want to try to direct the person to thinking about topics on his or her own. And at least I was very lucky that during my postdoctoral time, so it's very important to keep the fellows independent and not tied to your own research program. At least in theoretical physics, that works. So that is my one thing for postdocs. The second one is because I saw in question and answer people asking about Indian research versus European research or Western research. And particularly in theoretical physics, at least I have felt that it's a good idea to have actually postdocs from outside, who are trained outside, who are Western, who have grown in the different discipline, come here, and students and postdocs can learn from them in a very different way, which through their behavior. So that is another very important aspect of internalization of research and globalization of research, which contributes by people coming here. It's not some projects you write, and grants you get. That, of course, has to be done. But there is something about this human element, both for postdoctoral research, that I think is very important.
I know Kankanda has a lot of students, so if Kankanda briefly share his experience, that would be great.
You might know that I had a very bad reputation. I was a notorious PhD guide who is most foul-mouthed, and everybody has to spend one night in the lab. I never appreciated my students, even if the paper is accepted. So my thing is, even after hearing so many bad things about me, if a student comes, I think he has courage. And I don't care whether he knows something or not. I just look at the eyes of the student. If there is some little bit of spark, I take him. And then I said, if I cannot excite it, it is not it is my fault, not the student's fault. And C.V. Raman, I'm a great fan of C.V. Raman. And you know that C.V. Raman, what C.V. Raman said about how to make discoveries? He said, great discoveries does not need maturity of knowledge, but freshness of outlook. And his another famous quotation is that Indian mind is not inferior than European and American mind. What we lack is confidence. And if that indomitable spirit is to rise, nobody can deny us our rightful position. So I thought that only thing I think that whether the person can work very hard. And for that, I have only one small bias. I like to students from the village side. I will not take a very fat, happy looking it's a urban student. So, but normally whoever came to me, I think 90% of the students I accepted. But some students come with a very, I said, do you know that I am a very bad guide? I shout at students all the time. He said, I know. Then why you want to come? No, sir, your student got a postdoc with the Nobel laureate in Caltech. I said, no, that is not a motivation. You want a career. If you want to live with me for 4 years, and if you want to struggle, and if you have to enjoy the ups and downs of research, then I will take you. Unfortunately, this postdoctoral research worker I got through 2-3 postdocs, but this does not work in India. The reason is if a new student comes, new postdoc comes to our student or new student comes, they have not seen this kind of laser, this kind of special instruments. So I say that I will invest you 6 months. 6 months you don't have to contribute, you just learn everything. But that after that, you will have to generate new problems. But the postdoc don't come here to generate new problems. They want that they will get a paper and another postdoc abroad. That is a problem. But wherever I went for postdoc in Colombia, in 1 month, I started fighting with my PhD postdoc supervisor that we have to do something different. I told him this is his new problem. So it is different people have, but main thing is you'll have to live with a person for 4 or 5 years. If you like his personality, then he need not have to be he or she need not have to be very handsome or very beautiful. The thing is whether what Godbology has said, that there is some kind of resonance, that I excite, we excite. This is a, so when I see that the students, I said, first day they go and join. Have you learned the laser? Yes, sir. Yes, sir. That's very nice, sir. Have you learned how to do the cell culture? Yes, sir. I gave them this food and they are growing in numbers. I can see the brightness in their face, the happiness of joy of learning. So that is the best thing. Actually, I think that is the greatest social work, that you are telling the students that there is a lot of things, lot of fun in knowing new things. I don't know anything at all, but I have, this is the way I choose students. Unfortunately, postdocs, I did not get that kind of good postdocs.
Got it. So now if I come to Gagandeep with a different question. So Gagandeep, I would like to know your thoughts on Indian women in science and their challenges. What do you think about it? I will come to Rohini also on that.
I think she is much more the qualified person to speak about that. I can talk about women in medicine, which is a whole different ballgame.
Yeah.
I think one of the things that is important to understand, that there is a much, much greater proportion of women who work in medicine than for any other field of science. And I wonder sometimes whether that is the economic opportunities that it offers women. There is stability, families accept medicine as being an appropriate form of employment for women. But if you look at academic medicine and you look at women in medical research, that's where the numbers disappear, because research is not rewarding the way practice is. So lots of women doing medical practice, making serious amounts of money, and doing a good job with it, obviously, but you don't see women in research because that's long hours, uncertain times, and there is not monetary benefit after that. You could argue that long hours and uncertain times are also a factor of being on call, delivering babies, all of that applies, but there is monetary benefit associated with those approaches. So, yeah, I don't think that in the sense that we are talking about women in STEM, that medical women have it any easier than women in other fields if they choose to do research.
Got it. Rohini, would you like to add some challenges?
Yeah, actually, as usual, Gagandeep has said things very concisely and precisely about medical research. And this is a sort of I will make a small story, which I normally make. But I think the point, she has hit the nail on the head. I think the issues of women in research is actually, in my opinion, really and truly, the most important issue is the lack of somehow respectability of the career as a woman scientist in the eyes of family, society. And I used to actually give as a joking example that a mother-in-law is very proud when her daughter-in-law is called at 2 o'clock in the morning to deliver a very difficult baby, very difficult, attend a difficult delivery. And she's even proud, see, my daughter-in-law is such an expert. And there is this economic factor. I also tend to agree with that. And the same mother-in-law, if the daughter-in-law says that I have to go and turn over some Drosophila, these little animals from one container to another container, precisely at 3 in the morning, I have to change the 2 colonies. I don't think she will think that it's something respectable. Generally, can't you do it tomorrow? Do you have to do it in the middle of the night? Can you not do it at times after you have taken care of your child? Does it have to come today? So the fact that women would want to do research in STEM and at the same time also, have a good family life, just like a man has. We don't have that general concept. And I believe most of the hidden challenges come because of this attitudinal problem. Of course, there are very obvious challenges for women in research, which I will say and end actually. And that has to do with the fact that in many other professions, once you get your degree and you start a job or you start your career. In PhD, as we all agree that after doing a PhD, you need to do apprenticeship. You really need to develop your own niche area. And it is, precisely this time that by and large, your body clock is also ticking. So for a woman, actually, I find that the body clock and the clock of research is also ticking because you need to establish yourself, you need to do good work. And that is really an extra problem for women in research, and we don't appreciate that. And the solutions we suggest are all solutions to come back. But the point is that a good researcher, when I want to get to the top, taking a break for managing career and family or for having my family is not the solution. The solution is to create support structures. And I think in India, we still need to go quite a bit way to think about this. Though I must also say here that compared to the rest of the world, India, and the Indian government at least, and many funding agencies pitched in very early in terms of at least providing ways and means for women to come back. But I think the fact that the early researcher women, even PDFs, postdoctoral fellows, girls who are doing their PhD, all need support in this early period in case they choose to, try to defy both the body clock and the science clock, that they need extra help. support structures is not something we have appreciated. And I think it happens because we have a lack of appreciation of a woman's career in science. She can do it after everything else is done. That is that she can have the same burning desire that a man would have is not something understood and appreciated at a common level by all, including sometimes women themselves. I would say that.
Great. Asim wanted to add something.
Thank you, Shubhashish, for giving me a moment. Both Dr. Kang and Dr. Gorbole, I really appreciate your comments. And the earlier panelists as well made comments about postdoctoral quality. I have been fortunate to interact with some really outstanding women scientists who are going through the exact problems that you're describing. So Devesh and I, who's one of the panelists, are collaborating with this young lady out in ISC. She works with Manju Bansal, Devashriti Ghosh Dastidar. Now, here's a person who, if she were here, I would offer a faculty position. Because she's doing a postdoc in India, and this is also because of family reasons, right? She cannot just pick up and leave. She has a child or two now. The scientific ecosystem in India values her less because she did a PhD in IIT Madras. She did a postdoc at IIC. She's not considered on par with people who got their degree perhaps with me or postdoc at Stanford, right? And so this talks to the question that Dr. Bhattacharya was raising, right? We don't get really good postdoctoral fellows. Actually, I find that you have in India really talented postdoctoral fellows, mostly women. They finish their PhD and they go into this body clock challenge that you're describing, right? The biological clock. They get married, they have children, and that, typically makes, terminates their career, right? What you raised here today, Dr. Gorbole, is finding a solution to that challenge. And so rather than me continue further, I have this one example of Devashriti. We've been working with her because she's a computational person. So it's been possible to do this while she's raising her children. Now the challenge that she faces is she cannot find a career, she can't get a faculty position because she doesn't have the same trajectory as someone else who will leave from my lab this summer and get the job that she really deserves. Now, what is the solution that you propose? How should one go forward?
May I add something here?
Please, I'm looking for your advice, both of you, everyone on the panel.
I think one of the things that I believe, and this is something we suggested in the SNT policy in the equity and inclusion chapter, in fact, that I think India has to, going forward, India has to, in fact, remove what I call ageism. That, many things have an age limit. So the idea would be to consider a person's academic age and not biological age.
That's right.
Academic experience. So the milestones should be 10 years, 5 years after your PhD, after your 10 years after your independent lab, 15 years after your independent lab, and not, and if officially this happens, that would be one very important thing. Second thing which I have been advocating, which is on a very small level, but which I think can actually do good things, is when women, for example, when somebody is a postdoctoral fellow, like you said, the student who is in, I don't know the name, but somebody who was in IIS. Now, I normally find that if it is clear that these women have had, slow progress because of these other responsibilities, the many early career research schemes that we run should actually be take into account this issue when we evaluate these women for the early career research. And it's not just women, I would even say men who have had to take a break. I mean, in the US, normally it will not be, it will only what will be considered is the work you did. And this I've seen in the West quite often. Or in even I sit on many committees for International Union of Pure and Applied Physics for their awards. And a natural sentence is active research career. So but this is something we have to give to this is something that has to be built into the system. And if the system, the funding agencies, governments come tomorrow and say that yes, you can take into account such breaks, and you can take into account what we call academic age rather than a biological age for many, many different things. That can go a long way in compensating for some of these early career obstacles. And particularly in the early career, because the period you lose is a big fraction of the period over which you are being evaluated. I would not say that if you are evaluated 15 years after you have set up your lab, I would say it's fine, but it is this early thing that is very sensitive. So this is our solution, in fact, that we have suggested. And I don't know if this will ever get actually implemented. I have hopes that, because for example, Welcome TBT group already implements this kind of a thing. That if a woman postdoc gets a child within the postdoctoral period, they actually extend that fellowship by 1 more year, wherever she is, so that she gets time to come back and build what she needs to build in the remaining period.
How do you make this happen in India? At what policy level does this change have to happen?
As I said, I have suggested this in the policy document of the Science and Technology Innovation Policy of 2020. Now, if Indian government tomorrow accepts that, which is a draft policy, it's come out. Now, taking that policy, once it becomes a policy, once Department of Science and Technology says this is our policy, Department of Science and Technology's terms and conditions for its funding and projects would change. So I think we have to work at it, but I think this is at least going in the right direction, in the sense that this time the science and technology policy people decided that they would have a chapter on equity and inclusion in the document itself, and not as a special program for women. So I think that already is a good point.
And is there a way to encourage women who have decided to continue their postdoc in India and give them equal opportunity, if you will, as that given to someone who might come here? How would one do that? Are there special fellowships for this?
The way I see it is this extended early career fellowships. Where it is understood that this is, I think a lot of growing up on all sides is also required here. A lot of maturity. And that is where I began my first sentence, that it's how we look at women in research. I mean, 50 years ago, I was asked a question by somebody with whom actually I have written a graduate textbook. At one point, he said, "Oh, I didn't realize you are serious about research." And I mean, maybe he said it half fun, half jokingly. It's too long back. I can't judge it.
Maybe he said it because he was worried that you might outshine him.
That's right.
But I am just saying that it is this attitude, and it may not even the people may not even realize that they're saying, they would say it as a joke without realizing that this is something that could hurt a person, or this kind of unconscious attitude could bias the judgments you make about this person's job absorption, about this person's promotion. That is the point that I want to sort of make. And I think we can, talk a lot, but I think we can stop also here, because I think we have covered the major point, in my opinion.
Yeah, just, in the interest of time, we can also move to our next session. So in the next session, we would love to ask all of our panelists kind of very same question, that, what do you think, in which area India should focus? What are the research fields that India needs to focus in the coming decades? Maybe I will start the question with Professor Nagarajan. And I would also like to know that if he had any suggestion for the young PIs in India.
Yeah, so I think India is part of the global ecosystem. I mean, I don't think there are any challenges that are so peculiar and so unique to India that they will not have global relevance. So, but on the other hand, we live in India, and we are constantly exposed to everything that goes on around us. And I do think that we will develop research interests based on what we see. For example, I think socially relevant research is something that is now becoming a buzzword in a sense because of CSR funding. many industries are now being sort of forced to fund socially relevant research. And that has, I think, really helped many faculty who may have such natural tendencies to now have the funds to play with. It used to be that it was very difficult to get funding for particularly that last mile kind of connectivity. You may have wonderful ideas and concepts that you have developed in the laboratory, but how do you really take it to scale? And the support system for that was lacking. So I do think that the CSR initiative of the Government of India has been a godsend. I know that we have benefited extensively at IIT Madras. We have almost a quarter of our faculty who are working on projects that are CSR funded. And I mean, naturally, we tend to, I think, do research in three different realms. There's this very basic or fundamental research where you sit in the lab and write papers and journals and so on. And then you have this translational research where you're working with industry and you're trying to come up with solutions that are relevant to them. And then you have this, what I would term as transformational research, where you're not just trying to help one industry achieve something, but you're actually trying to solve a problem that the entire nation may be grappling with. And of course, it's not that we have three sets of faculty who work in these areas. It's usually the same people that are sometimes doing one kind of research and sometimes doing the other kind of research. Where I think we have lacked in the past is the funding to particularly support what I would term the transformational research. I think translational research is well funded by industry. Fundamental research is well funded by governmental agencies, but it's a high impact, large scale kind of work that academics have not been able to indulge in the past. And certainly India is very much in need of those kinds of solutions. I don't think it's enough if we sit in our labs and turn out papers, right? I mean, that's good. It's personally satisfying, and it helps the students who graduate and so on. But those are, unfortunately, that can very easily slide into incremental research, where you take something that's already been done and then just add one more layer to it, explore one more variable. What we really need is breakthrough research, because the kind of challenges going forward, not just in India, but globally, I think it's not going to be sufficient to do iterative research. Because things are, I mean, just take global warming as an example. It's not happening iteratively. It's happening, in a breakthrough fashion. And so any research that addresses it also has to be conducted in that same breakthrough manner. You have to be constantly trying to do something that's very revolutionary and not evolutionary, right? I mean, all those buzzwords that you keep hearing. So I think my advice is that exactly that, when you are getting into research, don't look for incremental problems. And those are the easiest, even a potential guide may tell you that, somebody else has already done this for this set of parameters. I just need someone to come in, do some more work with this set of parameters. It's very easy to say yes, and you will get your PhD in a few years. But then, is that the right thing to do? Or should you be saying that that's not what I'm interested in? I want to really take a look at something that is a big challenge that we face as a nation, and can I do something about it? And it may not be, and you may have to find the right faculty member. Not all faculty members may be willing or able to guide you in that respect. But I think if you find the right match and you start working with the right faculty member, either as a PhD scholar or as a postdoc, together you should be able to do wonderful things. But it does mean you have to do more homework. You have to see which faculty members are active in the particular realm that you are looking at, that you are interested in, and then go align with them, and I'm sure you'll do very well.
Love to know the comments of Sumukta.
I mean, Professor Nagarajan has actually summed up the situation so well. I thought I'd give a completely different perspective, and perspective a very, very personal for me. And I think when you're talking about what kind of areas India should move into, it's a very tricky subject, because India as a nation has, for most of its independent life, not really defined areas in which the country moves into. We've had labs and labs and labs where people have individually done things, and often with not much coordination between themselves. And they've chosen their own problems, etc. And only recently have you seen that there are national projects actually plugging into international projects. We were not even a member of CERN until a few years ago. So, and now we have mega projects. We are in many subjects. We are plugging into ITER, we are plugging into LIGO, we're plugging into etc. So, I mean, there these things are. But from my point of view, I think it is very important, as Professor Nagarajan said, to choose projects nationally as well, where one can involve young people and inspirational projects, right? Because for our generation, we went through undergraduate education not really knowing what kind of research opportunities there are in the country. And because we didn't see research active people in the universities, they're not there, just not there. They need to be more. And so we went abroad thinking that's the only place where we could do research. We want to choose places, choose subjects and choose projects and plug into the global ecosystem of research such that the young people can really see where they can go. They are inspired by them. And thus they can move into these fundamental projects rather than into incremental research. That is very important at the policy level for national projects to even at the lab level, even at the institution level, university level, for people to choose coordinated projects, maybe interdisciplinary projects, where a large number of young people can say, "Oh, that's a place for me, and that's where I can do some really important work." So, instead of naming projects, I think this is the attitude I think one should have in a country like India.
Okay, let's try to finish with some positive notes also. Kankana, I have a question for you. So, yeah, in India, we might have a lot of limitations in science, but what do you think, which are the great advantage of India have in comparison to the rest of the world? If you can, I will also come to the same question to the other panelists.
I think our greatest advantage is the number of young people. That is the demographic dividend. So we have a lot of young people. And my advice to all the young people is, don't take advice. Don't take advice. And nobody told me what I did in my life. And I will not tell Subhashis that next 5 years you should focus only on this. You find out your own problem. It is, and the the approach of research is different. If somebody wants to have, there are 3 kinds of research. One is called scholarship-driven research, which you do, I do, that with a few PhD students, we pursue a topic which I think scholarship-wise challenging. Second is need-based research, where we had green revolution. And I was very excited to hear that story of the Harish Iyer was saying about Biocon and all this pharmaceutical research. And another is big missions, what Somak Raychaudhuri was studying, CERN and other things. So it is up to you, what you will choose, what I will choose, what Somak Raychaudhuri will choose, what Rohini Godbole will choose, that is their choice. Only thing is, C.V. Raman said one thing, the highest scientific inspiration is one which comes from within oneself. He never, C.V. Raman never collaborated with anybody, did not have a PhD degree. And when after he got getting Nobel Prize, he was felicitated. He said that I am lucky that I did not have a foreign training, because everybody should learn to excel within their geographic boundary. Okay, so you should follow your own heart and do this. And since 28th February is a science day, which is coming very soon, so I think we should follow what our stalwarts. People will not remember Konkan Bhattacharya. People will still talk about C.V. Raman 30 years from now. And you know that what was the DST building? Subhashi, do you know what is the DST building? What was the DST building? Have you seen the DST building? Huh? Has anybody seen the DST building? What was it before? Huh? Somak Raychaudhuri?
I don't know. It looks like a warehouse. What was it?
That is a PL80 grant from
yes.
grain.
Before Green Revolution, India has to import wheat, and it was a PL480 go down. Then one Swaminathan prescribed. He was a scientist, but not a very high scientist. He said, you take the Norman Borlaug's hybrid set, India achieved Green Revolution in 3 years. And then that food import was not needed. And then 1971, DST was created. And this is a symbol of what is need-based research in India. And you know that we talk about Marie Curie's family has got 2 Nobel Prize. We have also a family with 2 Nobel Prize. You know who is that family? Raman and his nephew Chandrasekhar. And in Chandrasekhar, after getting the Nobel Prize, he recited a poem where the mind is without fear. It is a Tagore's Nobel Prize winning poem. It says, what is heaven? Heaven is where the mind is without fear and the world is not divided into narrow domestic walls. So narrow domestic walls means, I think I am chemist. I should not talk about or like what Somak Rai Choudhury does, or what a mathematician Rohini Gadbole does, what a medical doctor Gagandeep Kant does. We should follow an open approach wherever I like. If I don't know biology, I will go to Gagandeep Kant. I said, ma'am, you teach me something. If I need normally I don't do theory, but I have a very good friend called Biman Bagchi in IST Bangalore. I collaborate with him. So basically you have use a very open approach. And I tell the young people that I cannot advise you because I saw a mobile phone at the age of 50. I saw internet at the age of 40. Nobody knows. My nephew says that I came back in 1987. There was no mobile phone, no more internet in USA also. You remember? First internet came to India in 1994, and 1994 mobile phone also came. So basic thing is, with time you have to evolve in your own way. Don't follow anybody. So Raman did not follow anybody. Our Chandrasekhar did not follow anybody. Actually, people say that senior people try to crush young scientists. Chandrasekhar has the maximum humiliation. I think Somak Rai Choudhury can talk about that how Eddington insulted Chandrasekhar, and he finally got the Nobel Prize for the subject in which he was insulted. So the problem is, only thing is, we should have a democratic environment. In every institute, we say, what Rohini Gadbole is saying is very bad. What Subhasis is saying is very bad. Don't give judgment, respect everybody. If you respect everybody, you will have to learn, you can learn their subject. Respect, this is very difficult for a Bengali to respect. Bengalis actually cannot respect anybody. And I tell many of my non-Bengali friends, the Bengalis criticize, and that is the sign of admiration. If you are not criticized by a Bengali, you are not a good man. Okay, so take criticism, everything as an admiration, and follow your own heart. And then you will reach somewhere. Where you will go, it is your destiny. You will define that. Thank you very much.
Great, thank you so much. This is really inspiring. I will briefly go to Gagandeep and then Rohini, if you can address, and then to Nagarajan. Gagandeep, if you want to address some critical advice for the young PIs, any comments?
I think the most important thing is to think about whether you really want to be an academic or not. Because we tend to make our young people think only about academia. We don't give them other options. And the important thing to understand is that these barriers between academia, industry, policy, well, not so much policy, but at least academia and industry are becoming more porous. There are people that are moving back and forth, and there is a lot to be learned by not having a single pathway. Go where the work excites you. Go where there is interest, there is potential for impact, whatever your drivers are. But don't think that being an academic researcher is the be-all and end-all of life.
Fantastic. Makes sense, ma'am. Professor Nagarajan, if you want to say something on this field.
Yeah, I think I already mentioned that my advice to young researchers is exactly the same. I think they do need to do some groundwork to, they have to profile academics that they want to work with and figure out whom they want to work with, based on mutual interests. If you really want to do very theoretical, very fundamental stuff, then find a guide who will be good for you in that sense. Or if you want to do work with on some industry relevant project, then find somebody who's doing that. Or if you want to do something that will shake up your field, then find people that are doing that kind of work. I do think that the aspiring researcher has to play a very active role in figuring out where do they want to go. And because once you go and start working with a guide, you don't have many degrees of freedom anymore. You pretty much have to align with the research direction of your guide and of your group. And it's very difficult to then shift the paradigm. So that needs to be done, I think, before you start working with a particular research group. But I think nowadays there are so many tools available. You can practically find out everything that every researcher is doing. You can look at their publications, you can look at their patents, you can look at the work they're doing with industry, you can look at their student profiles, you can look at how many IP, patents they have filed. But you should do all that and then use that knowledge to guide your selection of guide. Then I think you'll be fine. Just avoid a mismatch.
Rohini ma'am, any closing remarks?
Yeah, I kind of agree almost in toto with what Gagandeep said, that I feel that, and I'm not, I think Professor Natarajan was talking about really very nuts and bolts, but I'm going to say something slightly different. I'm going to say that do what excites you. Choose what you want to do because this is what you want to do. Exactly. And be aware what are the kind of expertise that you require to do that. Understand those expertise. And if you do your PhD in one subject and then go and do something else altogether, it does not, actually it's quite good. So the important thing for me is you do things because you want to do them, because you want to know the answer. That you won't be able to sleep the night if you have not finished the problem. Again, I can talk only as a theorist. So if you haven't sorted out my problem, I may not be able to sleep the night. I think once you choose something because you want it. And here what I mean is that don't choose something because this is where lots of grants are going to come. This is the area which is a thrust area decided by the DST. So I can get a good grant. Maybe that's a practical approach. But to me, the real approach is do something because you want to know the answer. And most importantly, judge what you need to know the answer. And if you think you're not, for example, even Einstein, when he was trying to write his general theory of relativity, realized he didn't know the corresponding differential geometry. So he actually had to go to Grossman and say, please help me because I don't know the mathematics that is required for my physics idea. This was, of course, a very high level example I'm giving. But I'm saying that, if I'm an experimentalist, see if it's possible for me to get the kind of apparatus that is required to do this research. Do I have the money? Will I be able to raise that money? So when you are doing your independent research directions, think of these things when you're chartering. And interdisciplinarity, according to me, is the sort of grade of the coming days, I feel. And we see nothing more than that in the example of the research on coronavirus. So I personally think this is it. Do what excites you, but judge whether you can do it or not. Otherwise, you can spend a very unhappy life.
Thank you so much, ma'am. Thank you so much, everyone, for the great discussion. I think many young PIs like me, we learned a lot of things. And, I would also like to thank you from the Sciroi family for your precious time, for the interesting and great discussion. Thank you, everyone, for coming here. And thank you. So I'm handing over to Manali. Manali, if you want to conclude.
Thank you, Shubhashish, and all our panelists. I was really insightful. I can't tell you how, I had goosebumps listening to all this advice, and I hope, young people like us can follow in your footsteps and reach where you are currently. So thank you so much. We will be closing this session here, and we have a science showcase from young researchers in India coming up in 5 minutes. So I have already posted the link in the chat box, so you can directly click on that link to go to the other session. It will start at 9 p.m. IST. So thank you everyone for joining here, and we'll see you there shortly. Thank you.
Thank you very
Yep.
much for organizing this.
Thank you.
And
Thank you.
Yeah,
good luck.
thanks.